Okay, so now what if we want to go from a rational power into the radical form? Okay, like I had said, there's only one concept here. You have to be able to do it in each direction. So if we started with a rational power, so a to the power of m over n, you need to be able to put it back into its radical form. Okay, so once you are converting into a radical form, you know there's going to be a root or a radical symbol. Okay, the base is a, so we'll write our base inside the radical. The power is m. We'll keep our power written inside the radical, and then the denominator is our index, and so we'll apply that here. So you're still using the same rules. You're still doing it in the same direction, or in the same order. You're just going in the opposite direction here. Okay, so if I gave you a number like this, 3 to the minus 2/5, and I asked you to rewrite this in radical form, again, you follow the same steps that we laid out in the last one. You'd write your radical, and you'd enter the base. And this base is written inside the radical. So our base was 3, so we write our radical and our 3. Okay, step 2, you apply your power, which is the numerator of the rational power. Okay, it becomes the power inside, so the 2. And now the fact that it's a negative 2 tells us where is this base going. It's in the denominator, so I'm going to write this as a fraction where that base is in the denominator. And then your final step here would be to apply the index, which is the denominator. Okay, so our index was this denominator 5, and so we're going to write that as our index. Okay, so when you simplify this whole thing, since 3 squared, we actually know what that value is. We can rewrite this as 1 divided by the 5th root of 3 squared, which is 9. And so this would be our radical form. Once again, we're going to talk about simplifying or rationalizing denominators and simplifying it. This does not fit those last 2 rules of a simplified radical, since there's a radical in the denominator. Okay, but for what we're doing right here, just in converting the forms, you can leave that radical in the denominator. Right, so what I would like you to do with this is see if you could answer these 4 parts to sample problem 12. All right, so let's take a look at these. The first, if we write our radical, our base of y, the power is 1, so we don't need to write anything there. The index is 7, and so we get our answer here. Now remember, when you're typing this in online, you type in 7th RT for 7th root, and then whatever's inside that radical will go inside parentheses. Okay, the second example, again, even though it's an improper fraction, okay, when we convert it, we're going to take our radical, a base of x, a power of 3, index of 2. We don't need to write anything because it's a square root. And so here you do have that simplified form where the conditions are not met. The power is greater than the index, so we do need to simplify. How many groups of 2 can we remove from 3? 1, so we can bring 1 x out. And how many x's are left inside the radical if we remove 1 group of 2? 1. Do we need to have, and again, we have an even indexed, so we do need, or an even number in the denominator. So we need to consider whether or not absolute value is required here. So looking at this original form, and again, it's probably easier to look at the radical form of it, is it possible for x to be a negative? If you take a negative and cube it, you still get a negative. Can you take the square root of a negative? No, so x can't even be a negative, and that restriction is shown in the simplified form, so you don't even need to worry about absolute values. It can't even be a negative number. Right, the next example, we take our root base of t, power of 3, index of 2. Now, because that power was a negative, it's going to go in the denominator. And so here, for this one, because we haven't talked about simplifying radicals in the denominator, you could leave it in this form. You could also reduce it, knowing what we know. We can remove one group of t, or one group of two t's out, becomes a t, and one t stays inside the radical. So either of these forms would be fine. We'll talk more later about how to rationalize this. And then the final form, and again, you would consider the possibility of an absolute value. It's the same form as b, so you know it's not going to need absolute values. Okay, the final example here, we take our radical, base b, power of 1. Now it's a negative 1, so it's going to go in the denominator of a fraction, but we can leave it unwritten, an index of 2. And so again, same thing, make sure you check to see, do you need absolute values around this? B can't even be a negative in this form, so you don't need to worry about absolute values.